All right, so this week we're going to talk about something different. And I like to start with something simple. If we were to address the number of step downs that we had over last year or so on the Linux kernel alone, things might sound a bit chaotic. And I think it's about to get even worse. A while back when the Linux kernel got the Android capabilities, or basically support for Android devices, there was a period of time where the kernel development was slightly chaotic. Even led to basically being kept aside in a different branch. Eventually things coalesced. And that is one of the things that I'm going to establish a parallel with. Recently, the Rust finding its way into the kernel and the push for memory safe languages to be used everywhere and anywhere is raising a lot of eyebrows. It's leading to a lot of step downs, a lot of stories about developer burnouts. Whether or not those numbers are bigger or smaller than they used to be is something that I don't believe that anyone could ever answer. Regardless of that, why is there a push for this? Well, this is, as I said in a different video early on, this is not a new story. Okay, this is not something new, not even code generation. In the past, it was made with highly abstract code. This time is made by AI. The issues are pretty much the same. Maintaining it is an issue. And the gross majority of the issues that lie at heart are basically that. Maintaining a piece of software is actually a lot harder than creating a new one. The reason why the Linux kernel has been so successful is actually something that not even Linux itself was quite able to understand its true reason. It's basically a magical combination of factors. At that point in time, a lot of people knew C, a lot of people were interested in OS development, were able to get something started from the ground up, and it magically worked. It worked so well that for a long time, they actually made development without even a code versioning control system in place, which is completely out of this world. Over time, we've seen changes in the way Linux itself manages the project, and this is becoming even more clear, especially when we start to see the fact that the project might be succumbing to the external pressures, like supporting Rust. I don't think that everyone in the project believes that Rust is a silver bullet, especially after the CVE. If you're not familiar with what I'm talking about, we're talking about this here. I'm going to transition into it. We're talking about this. Basically, an issue that at its heart is based on the fact that you have an unsafe block in it. And people pro Rust will say, well, it's an unsafe block, so it's bound to have issues pretty much like any other language. The question that I want to raise is not that. The question I want to raise and live here is, why is there an unsafe block here, right? Are there any conditions in the language that when faced with kernel level development or interacting with hardware or any other condition that makes this into a requirement? Because if we take this here and if we take that there, and we take a look at and we do something silly, right? let's say you're questioning whatever or not is worth spending time into finding bugs on Rust-based code on the Linux kernel. One might just do something like do a find on the project itself, find anything that ends in RS. I'm not even sure if this is the only extension, by the way. And then do a grep for Unsafe. Like it is bound to have a lot of things, commented code that I know that they're there because I ran this before. But we're going to see quite an impressive number of those. Having 2,552 entries in a kernel of the size of Linux might not be something that would be worth noting. But what is worth noting is the fact that this is still up until a very short period of time was still considered as an experiment, which means there's not much written in Rust yet. And still, just out of its first batch of official code, we have a CVE and we have 2,552, right? 52 entries. I want to be wrong with the numbers here. So, yeah, 52 entries, potential entries of Unsafe. I know at least one or two entries of those counts are actually come into the code. Let's go on the safe side. Let's say 2,550. Okay. Why is that? Okay, there might be something into it or not. Okay. And then we're going to start to address the another issue. We have one step down to kernel co-maintainer. Alex Hirri, this was a while back. There's a lot of novel here. It's basically leading into a statement that I find very peculiar, naming someone the sole official maintainer of the Rust kernel code. I hope this doesn't mean that this is the only one doing that, because that would be worrying. The fact that Rust also has, and this is in the documentation of the Rust kernel itself, the consideration of using cargo, which is their package management, to leverage dependencies that are already implemented into the kernel, brings another threat into it, which basically means the kernel might be prone to supply chain attacks. It is an uncomfortable situation. Another step down here, and I'm going to. So this is the case that I was just talking about now. There was another step down here. This one talks about a statement that I don't. It might be related to a particular geography, culture, or whatever. I'm not familiar with this. Try to get to grips with the meaning of this, positive, negative, whatever. I couldn't get my head around it. But based on the writing, it seems that this was basically the drop that made the cup go over, go over, and one of the most human traits ever. We take things too personal most of the time. We transport our own realities into the work we do, especially in development. And sometimes we see things too personal. And this is what I think it's probably one of the examples describing the environment, and the environment itself as very problematic, and the community being the whole management and patching is just being basically a challenge. Another example here, which we're going to have mixed opinions here. On one side, things are going to, well, let's see where this is going. Other one saying, no, it was for sure a success. We have a CVE, we have a lot of code that looks exactly like that still, but yeah, it is a success. To me, that is a telltale sign of a project that is afraid of losing contributors. because the gross majority of the development, at least the prioritized development at this point, is basically development subsidized by corporations. Okay, Red Hats and organizations like, or cloud-based companies that rely on it heavily, and many other examples. There's nothing good or bad about it. It's just priorities. Okay. On the other hand, we have another example of what I believe it's probably how most contributors end up being involved, right? You have curiosity, you start playing with it, you eventually have an idea, you build on top of it, and then sometimes your hobby becomes your work, actually your work, especially if you're hired by a company, or you might find yourself in a similar situation to the one this maintainer was, playing with this, having it running in multiple devices. He goes over this quite. It's an interesting read. How he basically embraced the challenge of having this running on M1. And the technical challenges and the that led into, and eventually what I perceive based on what I read as a good omen. Like, had an immense support, a wide range of donations, which means the community might be interested in what he was trying to achieve. The issues lie after this happened, because this being a community-driven project, okay, either this gets the attention and the importance and the relevance in the kernel development mainstream to have it being brought in and have taken into consideration, or it's going to be really tough. And one of the reasons why that is so is because most of the development was made with zero vendor support and documentation, and one cannot expect any different, right? Apple and M1 built a platform on top of FreeBSD. Right? There is no reason whatsoever for them to make things easier for any other platform. It doesn't make any sense, neither in their strategy on the development itself or financial. Just zero sense. So all of this was basically with blood, sweat, and tears, and based on what I read, quite impressively, I may add. Now, this is one side of the equation. The other side of the equation is basically keeping track of something that is under heavy development, with the pressure that currently companies are trying to push. There are new devices being pushed left and right all the time, and no one is expecting for a device to be on hold, because the Linux kernel needs to pick up with the stuff that someone added to it to be able to support that very same device. So there's a lot of pressure here, right? And everyone needs to interact and make this whole thing work. Is it too big? Did it become too big? Well, there are examples of other projects like NetBSD that is able to support an insane range of devices and still function correctly. The way the project works is slightly different, and in some cases, most of those projects don't refrain themselves from losing contributors to ensure that the platform development stays stable. Apparently, that is something that, in case of the Linux kernel development, might not be the case. Whatever the reason why, if that's the case, the reasons why it completely escapes for the time being. And he also it also illustrates that we're not just talking about dealing with changes at Rust level. At C level, things are tough too, and one cannot expect any different, right? It's a highly moving target. There's a multitude of devices being added support for, embedded or not, And if we can start considering the hardware that is being currently used by the cloud environments, which for the most part might even be completely customized, it is an interesting challenge. It's no longer a hobby. Things might start to tip over when, after all of this, we put the community. The community will have its expectations on the project, asking where a particular feature might come, making hard comments about support or the lack of support in a few cases. And in case of something that ends up being a replacement, if I may use that way of describing, a replacement for the Mac OS, which is the native OS for that device. In this case of in question that we're talking about here. So this project attempts to be basically to make it so that you can run Linux on an Apple M1 CPU. I think it also supports later versions of the CPU, the ARM, Apple's ARM architecture as well. Comparing the battery lifetime of macOS is basically something that one would expect, right? It's actually something unique to macOS at this point in time, because macOS made it so that would be a marketing flag. Our OS, our laptops last longer because our OS is better. It was tailored to last longer on battery. Okay, this being a core flag, a core objective of the project, makes a lot of change, especially when there's where there's cache involved. Someone attempting to run Linux on an Apple device and realizing the battery life is not really there in comparison might be something that one might think. Now, whatever or not that individual is aware of the fact that there is a lot to do before you even consider battery life optimization, and the fact that interacting with the hardware is not the same thing as interacting with a web API, which seems to be the most relevant development experience we had over the last few years, makes it any OS level development at this point really scarce. The skills are not there. Not that many people have that level of knowledge. Not everyone is aware of the fact that you may have the very same brand, the very same version of the device in two different builds, still the same model, and yet you need the driver. The exact same code might not work on both cases. You might find yourself that you may need to tweak that code because there's a slight difference on one device. It might be one chip, it might be one transistor, something in there changed slightly, or the firmware changed, that will eventually make you have to deal with that. And for the most part, hardware interactions are typeless. The types that we have are basically a construct that we made up. And so on having something like Rust being strongly typed is one of the questions, whether or not something like that would be worth it. It eventually leads to, this is one of the latest step downs, a step down from the project altogether. And I think is basically a combination of two factors here. On one hand, you have the heavy lifting of work that needs to be made for your hobby to be kept afloat. On the other hand, you have the expectations of the community that supported the initial development of that very same project. It is a tough place to be. And if one considers, oh, with AI, certainly will make things easier for newcomers to be brought into the kernel development. I recently had a case where I was proven wrong. Okay, I tried to maintain an AMD override driver for a while. Whether or not I was successful for the first 2 times that I managed to get that thing running is a question that I won't be able to answer ever. But the last two attempts, when I updated the kernel, there were changes that I needed to make for that driver to be able to compile and be usable again. The first one was slightly easier. I was able to pull on my own. And apparently everything worked. Whatever or not that was solid, I don't know. The last one I had to use AI to help me out because the changes were too much, and it brought into deprecation of APIs, alternatives, and a few other changes that I eventually managed to get it to compile and run. Didn't notice much changes, with a few exceptions here and there, a few errors here and there in the logs, but for the most part, still usable. VMs still running. Not something that I worried too much about it. After the last one, even with AI, I was completely unable to do it. And I've worked with embedded devices in the past. I played with the kernel. I played with a few things. And officially, because I know that the level of work that I do at that level is beyond something that I could share with anyone, beyond acceptable. And the proof of that came after when that write driver ended up corrupting some of my files. Still, it doesn't make that easier, especially if you're doing it as a hobby. Okay. Now, I left something in as a Easter egg in a few videos before. Okay, there's a very cool project called this one here. It's a very cool project. It's called CVEs. Go through it. Truth to be told, this here doesn't illustrate any, as far as the project says, and as far as I know, I know even less Rust than anyone else. I haven't went through much about this, so I need to take their word for it. It is basically regular code, not code that you might see on a project, but is basically taking advantage of a bug that is being open on the Rust compiler in the last 15 years. And it basically puts a hole on their statement that Rust is memory safe. I like to pull these things here to illustrate something simple. Like the way you do this thing is you compile it. You basically do a cargo. What is it? Where is it? There are multiple ways of doing this thing. I'm completely alien to this part here. Even trying to debug it, it's no luck in there. You can do it this way: cargo run segment segfault. You're going to see this after you do it, or eventually if you do cargo install CVE, right? Eventually you get this binary here, which was the binary that I ended up running here. Okay, so you get a few options: that the buffer overflow there, and then the buffer in question is 124 bytes, and I'm sending one more character, and it basically blows up. Now, the reason why I searched for this is some time ago, I came across an issue with something called MDBook. It's also basically it's something that takes Markdown and converts it into an HTML pages. is basically used to build static websites. It had a segfault, and it's built on Rust. And I got curious there. The goal, as far as I know, is for Rust to be able to pick these things up at compile time, which might be led into. That is a lot of complexity to add to an already complex challenge, building a compiler. And so I was a bit skeptical of their capability, their coverage of it. The bug in question, I'm going to link on the video description, as well as the project. Go through it; it's fun. The code's barely readable, but any Rust code is barely readable. I'm yet to still be able to read that thing. And I want to leave this episode with one question. If the solution to the problem you're trying to fix makes it so that the learning curve is so steep that the people involved in the development of the technology itself burn out. The people trying to push and implement things and migrate things into that technology burn out. Is it really worth it? Because in the end, skill acquisition is what we are talking about. Even if you try to solve the problem at the compiler level, if in order to be productive, you need to fight a compiler for 1 year, one might question, well, in a year, you can learn a lot of C, and you can take a lot of lessons from bad code in C. Are we trading one thing for the other without realizing that we might end up losing a lot of very sharp and useful hands in a few crucial projects? And be sure to make sure you support whatever projects you use. I think it's really important to realize that a lot of people start things based on a hobby, and eventually every piece of software has bugs, and someone needs to fix them. Okay, and if someone is doing that just based purely on their own free will and time, I think if you can contribute with your own skills, I think you should do it. If you can contribute with something else, I think you should do it. If you are unable to contribute either way, and you have comments, do it gracefully and constructively. Okay? Don't expect someone to add a feature on something just because you think it's ridiculous not to have support for this and that, when you yourself can't implement it. If you don't know how to do it, you can't say that that thing is easy. It's ridiculous not to have this or that. Because in reality, you can't do it. And if you can't do it, you can't comment. And for the maintainers themselves, take every comment with a grain of salt. Don't take it personal. I think if someone says, this is easy, yada, either it's being sarcastic, and you should take that into consideration, or you should just blatantly ignore it. Otherwise, you'll always be miserable with your own accomplishments. And I think that example of that Linux distribution was quite an accomplishment, I may add. And that's going to be it. Stay frosty. Happy New Year. I'll see you in the next one.